Hello friends, today we are going to see part 3 of HPLC. We have already covered part 1 and part 2. We have already covered part 1 and part 2 of HPLC. In the previous lecture, we have covered part 1, that is basic principle and introduction, scope of HPLC, instrumentation. In part 2 we have covered the instrumentation in detail along with the detector. In part 3 today we are going to see the applications and system suitability parameters. HPLC is a chromatographic separation technique which gives us information about identification, quantification, that is qualitative and quantitative analysis. Mostly analytical HPLC focus on qualitative and quantitative evaluation of analyte or sample, while isolation of analyte is possible with preparative HPLC technique. The application of HPLC mainly involves chemical separation, identification, and purification of the analyte. Analytical columns helps in separation of analyte. It is based on the fact that certain compounds have different migration rates given a particular column and mobile phase. The extent or degree of a separation is mostly determined by the choice of stationary phase and mobile phase. Identification of analyte and quantification is possible using analytical column. The identifying peaks should have a reasonable retention time and should be well separated from extraneous peaks at the detection level which the assay will be performed. Purification or isolation is possible with preparative columns. Purification is defined as the process of separation or extraction of target compound from the mixture of compound or contaminants. Each compound should a characteristics peaks under a certain chromatographic conditions. The migration of compound or contaminant through the column need to differ enough so that the pure desired compound can be collected or extracted without incurring any other undesired compound. Now the applications are mainly qualitative and quantitative analysis is there for the HPLC. So in the pharmaceutical field we are using HPLC for tablet dissolution studies, then shelf life determination of pharmaceutical compounds, identification of active ingredient of dosage form, quality control studies, or stress degradation studies. Like this, various applications are there in the pharmacy field. Now in the forensic pharmacies or forensic study, quantification of drug in biological samples, identification of anabolic steroid in serum, urine and sweat and hair, forensic analysis of textile dyes, determination of cocaine and metabolite in blood. Here we are enlisted few applications, lots of applications are there. Now in the clinical field, HPLC is used to quantify low ions in the human urine. Analysis of antibiotics in blood plasma, estimation of bilirubin and biliverdin in blood plasma in case of hepatic disorders, detection of endogenous neuropeptides in extracellular fluid of brain. Food and flavor industry. Here we are using HPLC to ensure the quality and preservative level in the soft drink as well as the drinking water. Then analysis of beer or soft juices, then analysis of fruit juices, then analysis of polycyclic compound in vegetable. Like this, various applications are there. So lots of application here. We are enlisted few application of the pharmacy field again, such as analysis of drugs, analysis of synthetic polymers, analysis of pollutant in environment, determination of drug in biological matrices, isolation of valuable products, product purity and quality control of industrial product and fine chemicals, separation and purification of biopolymers such as enzymes or nucleic acid, water purification, pre-concentration of trace components, ligand exchange chromatography, ion exchange chromatography of proteins, high pH and anion exchange chromatography of carbohydrate and oligosaccharide. So such as lots of applications are there of HPLC in various fields. Now we are starting with the system suitability parameters in HPLC. So what do you mean by system suitability parameters? So system suitability parameters or analysis is a important method to prove that system is working perfectly before the analysis or not. It is to be done before the analysis. HPLC chromatography technique is used in pharmaceutical industries for research and testing purposes. Most of the pharmaceutical companies follow three-step approach to check the functioning of HPLC system, such as initial system qualification, method validation and system suitability testing. Some parameters which can be checked using system suitability testing are resolution, capacity factor, selectivity factor, retention time, telling factor, plate number, repeatability testing, etc. So such factors are there. They are called as system suitability factors. Here on the screen we are seeing that three spectrums we are seeing. A is a spectrum where two peaks we are observed of the analyte, but these two peaks are not well separated, means they are merged. In the B spectrum we are seeing that first and second peak is now separating, and in the third C spectrum what we are seeing in the third chromatogram, that first peak and second peak both are well separated. They have the proper shape also, that is the Gaussian shape peak, and proper separation is also achieved, and band spreading is decreased over here. So this is the ideal chromatogram. This is the C chromatogram. We has to, whenever we are injecting any analyte, so we has to achieve such type of chromatogram which is indicated as C in our analysis. So for this, to check whether system is performing properly or not, system suitability parameters are designed. Here this is the spectrum. Here generally this type of spectrum we are getting in HPLC. Here T0 is the called as gas peak or dead time, then T1 is called as, or TR1 is called as retention time of the first analyte, and TR2 is represented as the second retention time of the second analyte or component. So T0, this is the time required by a component to migrate through a chromatographic system without interacting with the stationary phase. Means whenever we are injecting our analyte, so some gas peak or if any means without drug substance or without analyte, if any particles are there, if it comes, or small peaks we are getting, so that is not expected as a analytical peak or a sample peak. So here we are getting mostly in the HPLC a small peak we are getting, that is called as T0. At the time of injection we are getting the small peak. So whenever mobile phase is coming out, so detector immediately detects it, that is called as the gas peak or dead peak. Here TR1 is the time required for component 1 or analyte 1 to migrate through the system. Then TR2 is the time required for component or analyte to migrate through a system. So this is the type of chromatogram that we are getting in HPLC. Now we are going to see the first system suitability parameter, that is the resolution. This is indicated by RS. Resolution is one of the most important parameter. Resolution is used to check whether critical separation is feasible under the given condition or not. Resolution is a function of column efficiency and specified to ensure that closely evaluating compounds are resolved from each other or not, to establish the general resolving power of the system and to ensure that internal standards are resolved from the drug. So resolution is defined as a method in which we are going for the quantitative measures, or it is the ability to separate two analytes is the resolution. Resolution is an ability to separate two analytes or two samples. Here we are seeing that WA is the first sample and WB is the second sample. W indicates the width of peak A or base width of peak A, and WB is indicating the base width of peak B where it has the formula uh, for the resolution. The formula is del Z divided by half in bracket WA plus WB. WA is the width of base width of peak A, WB is the base width of peak B, while del Z is the difference between the two peaks or retention time difference between the two peaks. So this is the formula we had to use to calculate the resolution ability of the chromatogram. Here this is the diagram from Skoog. Here what we are saying that in the spectrum A and B, these two peaks are there. So these are not well separate and having the resolution factor 0.75 after calculation using this formula or the previous formula. So here in the second chromatogram we are seeing that A and B are little bit more separated, showing the resolution 1. But in the third we are seeing that first peak and second peak, that is peak A and peak B, are well separate and having the resolution 1.5. So we require the resolution 1.5 or little more. So we can consider that our peak are well separated. So if we are having one resolution, so this indicate that our peak is not well resolved, but we are here we are getting 1.5 resolution factor. This indicate that our both peaks are well separated. Here according to this formula, T-2 minus T-1, that is this is retention time of second peak minus retention time of first peak, means del Z difference, divided by WA, half of WA divided by 2, means WA is the width of peak A divided by 2. This is the half width peak, and another is the half width peak of peak B. This indicate this formula. So according to this formula we have to calculate the resolution value. Then capacity factor, it is also called as partition ratio or retention factor, is the relation of time spent by a compound in the stationary phase to the time it spent on the mobile phase. Column must have capacity to retain samples and ability to separate the sample. It is measured for the position of sample peak in the chromatogram. When retention factor is less than unity, elution occurs so rapidly. When the retention time is larger than perhaps 20 or 30, elution times become long, or separation are performed under condition in which the retention factor of the solute lie between 2 to 10. Then selectivity factor is also called as separation or selectivity coefficient. Having this formula, it is a measure of difference in retention time between the two peaks and describe how efficiently a chromatographic system can separate two components. So here we are seeing this system suitability parameters in detail. Now in the next part, here this is the chromatogram. This indicate well resolution of all peaks. In the next part we are going for the quantitative analysis. We are going to see the quantitative